We tend to imagine that the gifted learner simply has a better processor, a brain capable of inhaling raw data at lightning speed and filing it away in a perfect photographic memory. Because of that myth, the average person starts a new subject by diving straight into the deep end. They try to learn the micro details, the technical terms, and the exceptions before finishing the first chapter. This approach creates a specific mechanical failure in the brain. Look at these disconnected nodes. When facts have no relationship to each other, they bounce around in your short-term memory, creating a state of cognitive overload that makes it nearly impossible to retain anything long-term. The problem isn't your intelligence, it's that you're trying to perform two different cognitive tasks, understanding and memorizing, at the exact same time. High-speed learners avoid this by reducing the load. They use a 6-step framework to build a structural map of a subject before they ever allow themselves to worry about the details. Step 1. Start with the map, not the territory. Don't memorize every street on your first day. Start with major districts and boundaries. In learning, this means finding the premise. Know why the topic exists and the problem it solves before opening a book. With that premise established, step 2 is a gradual descent from overview to detail. Instead of mastering everything in one pass, you layer information. Take Selenium. You start with its broad purpose, automating browsers. Move to components like WebDrivers, and only then look at deep details like locators. When you establish this hierarchy first, every new detail you learn has a pre-assigned place to dock. It transforms a pile of raw data into a structured system. Once the map is built, step 3 turns you from a passive reader into an auditor. You begin the "Does this fit?" test. For every new fact, you check it against your mental map. If it aligns logically, it clicks into place. If it doesn't fit, stop to investigate. This prevents building a foundation on conflicting facts or misunderstood concepts. Step 4 helps bypass the friction of difficult topics by turning abstract concepts into something familiar. The human brain struggles to hold on to pure technical abstraction. You can see this in how we explain an API. Instead of technical jargon, think of a waiter. You tell the waiter what you want. The waiter communicates with the kitchen and brings the response back. The waiter is the communication layer. Anchoring the unfamiliar to something you already understand makes the new information immediately usable, rather than just another term to memorize. That brings us to step 5, visualization. Brute force repetition is an exhausting way to memorize, because words on a page are difficult for the brain to grip. You can make information more durable by bundling multiple abstract ideas into a single cohesive mental picture. In programming, abstraction becomes an elevator. You press a button to go to the 10th floor without needing to see the cables and pulleys. Encapsulation becomes the building's outer walls, keeping the internal machinery protected from the outside world. Finally, step 6 is the reconnection cycle. Real understanding doesn't happen in a straight line. It's a loop. You take what you visualized, ask deeper questions, and then reconnect those answers back to your original map. Every time you complete this circuit, you strengthen the neural pathways associated with that information. Because human memory is built on associations, this cycle makes recall much easier. You aren't trying to remember a single word in a vacuum. You're remembering a piece of a larger, interconnected web. The difference between these two approaches is purely structural. One learner is attempting to juggle a dozen loose, disconnected facts. The other has those same facts securely locked into a framework where every piece supports the others. In an age where the world's information is available in seconds, the ability to store massive amounts of raw data in your head has become less of a bottleneck. The real competitive advantage is now structural efficiency, the ability to take that data, organize it, and map it into a usable model faster than the people around you. The next time you face a complex subject, don't start with the first sentence. Close the book, zoom out, and find the map first.